Martin and I are doing the review questions for Module 11. We're going to do question number 5. Martin, please read it to us.
What kind of solute dissolves best under high pressure conditions?
Okay, so this is the same page that we're going to be looking at, page 362, and it has the rule of solubility. So solid solutes, you can get them to dissolve better with increased temperature. Liquid solutes are not affected by temperature or pressure, and gas solutes are only affected by pressure. Solid solutes and liquid solutes are not affected. Their solubility is not affected by pressure, but it is for gas. So what happens if you increase pressure?
Then it increases the solubility of gases.
Right, so it's a direct relationship. So the answer for number 5 will be gas solutes dissolve best under high pressure conditions. Ready for number 6?
What kind of solute has a solubility that is least affected by the conditions under which the solution is made?
This is the one that's not affected by temperature or pressure. Which one is that?
Liquids.
Liquid solutes. That's right. I know it's not a complete sentence. Oh, well.
If a solid solute is not dissolving well in water, what can we do to increase its solubility?
Okay, so what do we do to increase solubility of solid solutes?
Increase the temperature.
Right, so you can increase the temperature. As I properly should say, I can increase the temperature because it asks what I could do, what you can do. So,
if a chemist makes a solution in a beaker using water and a solute that dissolves endothermically in water, would you expect the beaker to feel hot or cold?
Okay, so let's stop.
You'd expect it to feel cold.
What is endothermic?
Endothermic means a process that absorbs heat. You can tell by the name because it has heat and it's in it. Exothermic is a process that releases heat.
Right. So, for example, my light bulb is warm to the touch. It's exothermic. It's releasing heat and energy, right?
Mm-hmm.
The heat is one form of the energy that it's releasing. So, an endothermic, it's going to feel cold.
Warm.
What?
It would be warm.
What do you mean?
Because it's bringing heat in.
No.
Never mind. Yeah, it would be cold.
Yeah. So endothermic reactions is how we have ice packs, right?
Uh-huh.
Endothermic.
What is the difference between molality and molarity? Well, that's simple. We just write down the formulas for both. Molarity is the number of moles over the number of liters. Molality is the number of moles over the number of kilograms.
But wait a minute. This is the same substance. This is a concentration. So it's the number of moles of what?
Moles of
solute per number of kilograms of what?
Solvent.
Solvent. Okay?
Okay, if you wanted to protect water from freezing, which compound would accomplish this best? NaNO3 Mg open parentheses NO3 close parentheses 2 or Al open parentheses NO3 close parentheses 3.
So this has to do with our freezing point depression formula. Martin, I think you just went past it. Stop.
Sure, it's a formula.
Stop.
Okay.
What is the freezing point depression formula?
All right. Delta T equals negative I times Kf minus times molality.
Okay. So what is the I in this equation? Refers to the number of ions, or if it's a covalent compound, molecules, right?
Yes.
Okay, so stop.
I think
Don't turn the
these are
page. Thank you.
simpler than that.
Tell me what these substances are again. MgNO3. What's the other?
There's two others.
Would you read them to me? I know that.
NaNO3.
Sorry? Na.
NO3. Also, that was Mg open parentheses NO3 close parentheses 2.
Right. NaNO3. And what's the third, please?
Al open parentheses NO3 close parentheses 3.
Okay. You cannot turn the page. You cannot look anywhere. You have to tell me which of these is going to depress the freezing point the most.
It's Al.
Tell me why.
Because it's got 3 of the thingy.
Okay. Ions. So
Yeah,
what's the I
nice
going to be
ions.
in this equation? 1, 2, 3.
Yes.
What's the I in this equation?
4.
1, 2. This is a polyatomic ion, nitrate. You have to know it. You have to see it. You cannot.
Okay.
Don't interrupt me. You cannot, unless you're told that it's going to break apart. It does not break apart. It will stay as the polyatomic ion nitrate. It will not come apart.
Okay.
How many ions do I have in this?
2.
Thank you. How about in the third one?
4.
Yes, you have 3 and then 4. So if I'm multiplying by 2, 3, or 4, right? What's going to be the biggest delta T?
Or lowest.
Okay,
It's
the
gonna be
biggest
the
negative
third
delta
one.
T. Yeah, the one with the most number of ions. Okay, so I don't have to do the math. I don't have to figure it out. I don't have to know the KF. I just see this is going to have the most I's. The number I, the letter I is going to be the biggest in this one. So it's going to have the biggest freezing point depression. Okay? So that's the compound that will accomplish it best. And that's it for this equation, or for this review question set. Thank you, Martin.
All right. Goodbye.
No, thank you, Martin.
You're welcome.